All right, so when you think about programming and you think about coding, what do you typically see in your mind? You see somebody sitting in front of a keyboard, in front of a monitor on their desktop or laptop, and just typing away like a mad person, right? It seems like they're just spitting out line after line after line of code. But is that really what programming is all about? Is that how you get to program a large-scale product? Or is there more involved? The answer is obvious. There's a lot of planning that goes into creating a product in terms of creating something that's production ready. The thought process is extremely important, and you have to be able to get yourself to the point that you know exactly what you're going to do or have a very good idea what you're going to do before you even type out your first line of code. Now, the reason is because if you just jump on the computer real quick before you even plan out your project, what's going to happen is that you're thinking while coding. And that might seem like the natural way to go about it, right? Just sitting there, you're working and you're coding. But if you don't plan properly beforehand, that's where you could run into issues in terms of having the least efficient possible solution, especially if you're new to programming. Ultimately, the essence of programming is problem solving. All right, so let's talk more about it. All right, so let's look at a basic example over here. What I want to do is give you something to think about in terms of a possible problem. Let's say you have a list of items, an array of items, and you want to be able to determine the frequency of an element within that array. There's a couple of ways to go about it, right? So you could use a brute force method where you iterate over the array. Let's say you create a function, and in that function, you have a couple of for loops or a couple of for each loops, depending on what language you're using. But basically, you're looping over each element in the array, you're keeping count, and then you're iterating over the array a second time. You're eventually going to get to the result. You'll eventually end up identifying how many times an element is inside of that array. But then the issue of the efficiency of your program. And of course, that's where big O notation comes in, right? So if we're looking at that brute force method of looping over the array, counting each item and then looping over again, the time complexity of that is big O n squared. And that's not really efficient. The better way is to use something like a hash table or a dictionary in order to have a more efficient and optimized and more performant program. By doing that, you'll only have to iterate over the array once. So in that situation, your time complexity is just big O n. Now, why does this matter? Well, it matters because we have limited resources when we're talking about computing time, when we're talking about the hardware, when we're talking about the specs of the computer itself. And if you have multiple processes going on at the same time, if you have inefficient code, that can definitely cause an issue for you in the long term, especially the larger the array gets, right? So when you're thinking about programming and if your first instinct is to jump on the computer, open up your IDE, and start pounding away at the keyboard, you first have to plan out what is the ultimate goal. Thinking like a programmer in terms of decomposing what it is you're trying to do. Take the larger goal and break it up into smaller goals. And by doing this, one is not going to be as overwhelming as trying to tackle something so large, right? I mean, it reminds me of a quote that Abraham Lincoln, former President Abraham Lincoln, is attributed with saying, if he's given 6 hours to chop down a tree, he'll spend the first 4 hours sharpening his axe instead of just jumping in and trying to chop down the tree with a dull axe. Now, I mentioned that because it kind of makes sense in the context of, a programmer. When you're thinking about a particular problem you're trying to solve, you have to break down the problem into smaller problems and try to solve each of those smaller problems. You can use things like flowcharts, you can use pseudocode. Pseudocode is big in this because you're not actually writing code, but you're thinking about or you're framing up what would be the structure of code. And you can use mind maps as well. Whiteboards are often used. Whatever tools you have, even if it's paper and pencil, where you're just writing down your notes and you're starting to brainstorm in terms of how to solve that particular problem with code. You're thinking about it first. The thing is, it's also about a balance, right? You don't want to spend all your time just thinking about the problem and never actually writing the code, because you're never going to have a perfect solution on day one. So you have a framework of an idea of how to solve that particular problem. You have your flowchart, you have your pseudocode, you have your mind map, you have your tools, whatever it is you're using. And then that's when you actually start writing the code. And then you start testing the code. Then you start determining, is it the most optimized and the most performance way to implement what you're working on or implement your solution. I mean, obviously typing out code is a lot more fun, right? You feel like you're actually doing something. You feel like you're being productive. And sometimes you have to do it that way. Sometimes you have no choice but to just jump on and start coding. But in an ideal situation, in an ideal scenario, you should try to plan things out first. As they say, proper prior planning prevents poor performance, and that is really true when it comes to programming. If you want to have the best possible rough draft, because again, your first iteration of that program or your first rendition of that program is going to be a rough draft, and you're going to fine-tune that over time. But if you want to have the best version of it, a little bit of prior planning is going to go a long way. A little bit of thinking beforehand. So programming is about thinking, not just typing. Again, when you think about a programmer, you might be thinking about a person just typing out at a keyboard at 1,000,000 miles an hour. That's the picture we have in our heads. When really, it's a combination of planning the project, planning the solution to the problem, and then writing out the code. All right, so hopefully that made sense. I want to give you a very simple demonstration with the array and using a brute force method of trying to find the frequency of an element in the array, and then also giving you the other option of using a more optimized approach. Now, I don't want to go too deep into big O notation in this video. I'll do another video on that because it's such an important topic. And some people say, well, is it really that important? Ultimately, it's about writing efficient code because, your time is money, and processing time and the resources of the computers that we use, that is limited. We think it's unlimited. It feels like sometimes it's unlimited, but in reality, it is limited. So the better you get at writing efficient code and the faster you can write efficient code, the better off you'll be in the long run. All right, so in another video, I'll cover big O notation. I'll go deeper into the whole entire concept and then maybe do some more videos. I think I already have like 1 or 2 videos up already about algorithms. But I think data structures and algorithms are very important because they help you understand how to write performant code. And then you get to understand the issue of time complexity, how much time and how much space is required based on the code you're writing. All right, so you know what to do. It's time to plan out your projects, start planning the solution to the problem you're facing with code. And then once you have a good plan set up, once you have a good idea of how to possibly solve that problem, that's when you jump on the editor. That's when you jump on your IDE and start pounding away at the keyboard like a mad person. All right, so that's enough listening to me. You know what you got to do. Thanks for watching, and I'll catch you in the next video. Happy coding.